We are now in the dome of 1 meter telescope of Burakan Observatory. This is a very famous place. My name is Mաղաքյան. I am working here in Burakan Observatory for 47 years. When I came here, I was a young man, I can say student, and started my career here as an assistant astronomer. Now I am chief research associate, and I am still very active, I think, of course, to do some interesting science. I should tell that when I was studying in the 8th grade of school, so I was about 14 years of age, I visited observatory and have been in this same place here, and I was so impressed by this telescope, and I was always interested in the natural sciences, especially in physics, mathematics, astronomy, and I decided that I will be an astronomer. This place is very important for the Burakan Observatory. This telescope which you see behind me is very famous. It is 1 meter Schmidt telescope. It was started to work in 1960s, and very many important research were done with it. Especially one should note the Mağաքյան survey of galaxies, and also a search of so-called flare stars. These are important works which are even, for example, Mağաքյան survey is now even considered as an important item for UNESCO culture and science objects, and is kept in Burakan up to now, the place of this survey. And this telescope was working very heavy, I would say, for the 80s, 1980s. And then, after the various political and economical difficulties, it stopped operation. You see, as the light receiving equipment, the so-called astronomical photographical plates were used. And now nobody uses such plates, they are even not produced. But in the about, I would say last 10 years, we decided to revive this telescope, to bring the new life, and with help of our colleagues with various institutions from Armenia, from Russia, and various firms, there was installed a new equipment here. The fully was changed the positioning system and the control system of the telescope, computers, and for the light receiver, the modern charge couplet device, or CCD, was used. Now we can obtain the beautiful images of the sky again, and with various filters in various colors, and this is very important for the our studies. I will explain what we are doing here just now. You see, I'm now a head of department, but for all my time in observatory for 47 years, I was working in one direction. We were studying the young stars. the problems of star formation and various, I will say, phenomena which are taking place around young stars. And it was really one of the important things for that time and now also, because Burakan Observatory is one of the places, there are very few, where was proved that there are stars which are young. It means that they are young in astronomical sense, of course. Their age is about 1 million years, for example. But if you compare it with the age of the sun, which is about 5 billion years, you see that they are really young, of course. Then, after work of many astronomers in Burakan, in the United States, in Russia, in many countries, in France, it was found that there exist so-called star-forming regions, the places where stars are born, and they are born in groups. This process is ongoing. It is take place about several million years, and we see new and new born stars. Then after some period, this process is stopped, and these stars are starting their life in the old Milky Way galaxy and replenish it with their numbers. So we always see in sky, in night sky, of course. We see the young stars and old stars, and all this is very interesting and very important for the development of science. So, how are stars born? It was a difficult question, very difficult. And in Burakan, for example, Victor Hambartsumyan, who was its founder of the observatory, he for some time was thinking that the stars are born from the high density matter which is not known yet. Other astronomers were thinking that the stars are born from the material of the gas clouds which are in our galaxy, that they are brought in spheres by gravitation forces, and then they start to be stars. From gas clouds, they became stars, and then they developed the planets. These two views were in various ways supporting one of each other and contradicting, but at last we now understand more or less well that the stars indeed are born in the dark clouds, that they are born just now before our eyes, and when a young star is already created by various physical processes, of course, then it starts to expel the matter from it, it starts to hold a matter outflowing of some of amount, and it creates a beautiful outflows which, for example, about only, say 30 years ago, they were found by astronomers that they are so-called collimated. What means collimated? It means that when the matter is outflowing from a star, look, for example, for the sun. Sun also is a star. Then you will see that from sun we always see various mass ejections which can be seen on TV. You have listened about the so-called magnetic storms, and polar lights and such things, which all is produced by so-called sun magnetosphere. But in young stars, the processes are much more powerful, and this outflow of mass is going into jets or sheets of matter, like two very narrow jets which are going out from the star, from the poles of the star, and transferring in the, propagating in the space between the stars for very large distances. For example, up to several parsecs. I want to recall that 1 parsec is the distance, even more than 1 parsec is the distance from the sun to the nearby star, the Alpha Centauri. So as you see, the processes in one star can make an influence to the whole space between the stars. All this is very interesting and should be studied, of course. And what we are doing here, we are studying just these processes. So, perhaps I will tell you a little the history of this very interesting phenomena, because the mass ejections from the stars are really recent discovery. About 70 years ago, in 1953, two well-known astronomers in the world, one from the United States, George Herbig, one of the most famous observers of the sky in 20th century, and another one from Mexico, Guillermo Haro. They found an interesting objects in several places in the sky where there are dark clouds. They found nebulous patches which were had a very interesting spectrum, which cannot be so easily described and by the physics of that time, usually used in astronomy. And very soon, Victor Hambartsumyan suggested to call these objects the Herbig-Haro objects, and this name is used up to now. So it is the name of these categories. You see, after 20 years of studies, in 1970s, astronomers at last understood that these nebulous patches, cloudlets, are moving from the stars, from the young stars, and with very large velocities for the stellar objects. I mean, in the stellar world, the velocity for 200 or even 500 kilometers per second is really large. And they had so large velocity indeed. And what was the reason how they were produced near the stars? Nobody understood that. And work was continued. And only in the 80s, I can say in 1980s, yes, several groups of observers found that they can see not only these small nebulous cloudlets near the young stars, but also very narrow, well, I can say, like pencil sharp streaks which are going from the stars up into the interstellar space. They were called jets, and these jets are what we see, the ejection matter, which is going from the stars and into the space with high velocity, and then when it goes to more distant places, it produces these, how I described it already, the RBR objects, and then continues and at last dissipates in the interstellar medium. So, what this means? This means that if we have a method or means to find these nebulous patches, we can find also the young stars, because they are the manifestation of stellar activity in the the first stages of their evolution. And so such techniques were developed, and we also in Miracle started to search to find such RBR objects in very many places in the sky, which is observable from the Miracle. And not even from Miracle, because with our colleagues from other observatories, we also made some observations on the other places in the world, for example, in the southern hemisphere. And I should say that now the number of known RBR objects exceeds 1,200, and about, I will say, about 200 or 300 of them were found in Huracan Observatory by our group. This is serious achievements. And we are continuing these studies. At first we were doing this with our 2.6 meter telescope. But now we have in our possession again this telescope, which you see here, and it has a much larger field of view. And so you can study some clouds, dark clouds in the galaxies as a whole, and this is very powerful telescope, in fact. And we have found already, these observations were started 3 years ago, I will say. And these 3 years we found a lot of very interesting objects. There are new star-forming regions, new outflows, a lot of various phenomena which should be studied in more detail and discussed. Well, this is one of the directions in which we are working. And I will shortly describe another one where we also have some achievements. There are variable stars, a lot of them. Usually stars are not changing their brightness, and when they start to change, they become brighter or fainter or something else, for example, show eruptions. All this is very interesting, and these are unusual phenomena. And among a great amount of variable stars of various types, which are and old ones, very old stars, and young stars, and everything, they were found several stars which have very unusual feature. They are young stars. They became brighter, for about 100 times more brighter than they were before, and stay in this condition for many years. And they don't go down. Probably statistical analysis shows that they at last should return to their previous condition, but their brightest stage of their brightness should be about several thousand years. Such stars were called by Victor Hambartsumyan FUORs. It was a prototypic stars which was has the designation FU Orione. So it is in the Orione constellation, and by this name, F-Ori, all such stars were called FUORs. There are very few of them. Even now, with most modern methods and great telescopes and automatic searches and databases, only about, I will say, 15, imagine 15 4-type stars were found. Well, in the last years, perhaps the number came up to 20. And this is very interesting. This theory, how all these outbursts, so-called, take place and which is the mechanism of their production, is still not very well understood. And I should say about 5 such stars were found in Burakan Observatory, mainly by our. This is also, I think, a great success. Even more interesting is that Herbig-Haro outflows with many patches and strings which are going out for many parsecs are connected with such FUORs objects. Not all, but probably these stars, when the star became a FUORI type object, it ejects a large amount of matter in the space, and so it produces such large outflows. So we are working also in finding such objects, and just recently we found that the star, which was studied by us even in about 35 years ago, it was not found by us, but it was interesting, and we studied it, and we found interesting phenomena. But then, only 5 years ago, we found that this star became much brighter. At first it was changing its brightness, like waves. And now it starts brightening and remains there. But it was not a typical FUOR. So we studied all information we had in our possession and described it in a large paper. And then just recently, only several months ago, a large consortium of astronomers, we also in the world, international consortium, studied this star with very large telescopes, including the 10-meter telescope, Keck telescope on Hawaiian Island, and detail analyzed all that is taking place there, and came to the conclusion that this star is indeed forming something like a FUORI type outburst, but slowly, and this is a new type of such stars which should be then going up to some new future which we don't know. So this is another direction in which we are working, and I have no time now to explain all these phenomena in detail, especially for you, but you understand that we were doing here a real science which is going on more or less broad level. You see, there are many things which you can do, which one can do in astronomy. For example, one can study the objects which are near the edge of the universe. And for this you need a very serious telescopes in space. You have listened probably about the Webb telescope and other things. We don't have such huge telescopes and such a powerful equipment. But even with more or less modern, but not so large telescope, but with good ideas and, well, I say, discussed and put on observational programs, one can find very interesting places which are also very important for the development of astronomy. So, as I said before, I'm working here for nearly 50 years. And now, the situation is of course difficult in Armenia, but I think that I see that now several, I would say, interested in astronomy young people came to our observatory and continue our work here. I hope that perhaps some of you also will join to them, and because this is a very, I will say, important place, it is a national, what would we say it, treasure, as it was discussed by Armenian national parliament, and so perhaps it should be kept in more or less working condition up to now. I hope that it will not become only a museum. So by this I want to finish my talk, and if you are interested, I hope you will arrive in the Mağաքյան Observatory and see all these interesting things by your own eyes. Well, for those of you who are really interested in astronomy, I will say that it's of course very interesting. Astronomy is one of the most fascinating sciences actually. But you always should keep in mind that there are several things. For example, of course, at first it was very difficult. For example, you know, when you are sitting in the winter in this dome, it was very cold. Now we are doing observations from the first floor, from computer room. But again, the observations are not easy things. You should do modern observations. You should know about various difficult electronical and computer equipment, how it works, to keep it in right, and to light receiving systems are very, I will say, eligible to various effects of the weather and other things, so all should be done very carefully. Then, for example, if you work already on the obtained data, you again should do everything very carefully, a thorough study of your data to find errors. There are always errors, and you should eliminate them and do work in the high level if you want to be recognized in the world. And at last, I hope that you will not think about such things as an astrology and constellations, importance for the life of every man. Such things are, well, I will say amazing, but they are not true. So you can, of course, read such astrological predictions like an amusement, but the science needs the work. You should read the good books, written interesting things, and develop yourself. Of course, the science is not a main direction now in the world, because many people think, young men, that they will go into the business or information technologies or such things, but I think that several of you always will think about the natural sciences and astronomy, because you should remember, if you are working for the science, you are working for the ages. If you will do something, it will keep your name for the many years. So